Hi, I'm Emir Kerem Şahin, and I will be presenting my Physics 101 lab project, Equivalent Spring Constants. The aim of this project is to examine the spring constants of two separate springs, as well as the equivalent spring constants of in parallel and in series spring systems. For this experiment, I used two springs, a rope, a stand from which the springs can be hung, weights, and a 30 cm ruler. I hang the springs from the stand and I measure their length. Then I start putting weights on the springs and I measure the length of the spring on each step. This goes up to 450 grams, with the mass increasing 50 grams on each step. I do this again for the second spring, and I use the data to create a table, which I then turn into two graphs. Using these graphs, I can find the spring constants of the two springs by finding the slope of trend line. After this, I create an in-parallel system of springs by connecting the two springs with a rope. Then I do the same procedure and create the table and the graphs and find the equivalent spring constants of the in-parallel system. Then I obtain an in-series system by connecting one of the springs to the end of the other spring, and I do the same procedure. Using the spring constants of the two springs which I calculated earlier, I can calculate the theoretical spring constants of in-series and in-parallel systems. I then compare the theoretical number to the actual number that I found, which were very close in my experiment. The error margin of the in-parallel system was higher than the in-series system, and this can be explained by the lengths of the in-parallel system being much lower than the in-series system. In the end, this experiment found expected results with low margins of error. The errors in this experiment could be caused by the fact that the springs aren't ideal springs and by measurement mistakes.